Good morning, everyone. In this presentation, we will talk about UTP and fiber optic cables, which include characteristic, comparison, and network implementation. But before we start the presentation, let us introduce ourselves first. My name is Angguni. You can call me Nina.
My name is Putu Nadin Saskirani Putri. You can call me Nadin.
My name is Kadek Denis Krisna Febrian. You can call me Denis.
My name is Febby Anggariani. You can call me Febby.
Okay, thank you. And next, what is transmission media? Transmission media is the physical part of our data transfer between devices. The analogy is like a pipe carrying data from point A to point B. It affects the speed, distance, and signal quality. There are two types of transmission medium, which are wired and wireless. Wired are UTP and fiber optic, and the example of wireless is Wi-Fi and Bluetooth. This report is focused on wired media, which are UTP and fiber optic, because they are the most commonly used in modern networks. Next, what is UTP cable? UTP is a copper-based cable used in LAN networks. It contains 4 pairs, which are 8 wires, and it twisted together. Twisting reduces electromagnetic interference, EMI, and then it commonly used for short distance communication. The connector and standard of UTP cable are used RG45 connector, it's 8 pins, and the wiring standards are T56A and T56A B. It determines correct wire arrangement. There are two types of UTP wiring. The first one is straight through. The wire order on both ends is the same. It's used for different devices. Example, when we sending data from PC to switch and then router to switch. The next type is crossover. The wire order are different. Like pin 1 is connect to pin 3 and then pin 2 connect to pin 6. It's used for same devices like PC to PC and then switch to switch. The key characteristic of UTP cable is the max distances are 100 meters, speed up to 10 gigabytes. It depends on category and easy to install and also low cost. Next is performance. It works well for short distance communication. The maximum distance is 100 meters per segment. Beyond 100 meters, the signal will be weakened and data loss may occur. Performance depends on cable category, like CAT5E, CAT6, etc. The advantage of UTP cables are its low cost and affordable, easy installation without special tools required, widely available, reliable for short distance networks, and it supports 10 megabytes per second to 10 gigabytes per second. The disadvantages are sensitive to electromagnetic interference, limited distance, which 100 meter max, lower speed and bandwidth than fiber optic, and it's not suitable for high interference environment. Now we move on to fiber optic cable. Fiber optic is a cable that uses light signal instead of electricity. Fiber optic made of very thin glass fibers. It's enable very high speed and long distance transmission. The analogy is like UTP is for running, it's slower and short distances. And fiber is like we use bicycle, more faster and long distance. The key characteristics are extremely thin, thinner than human hair, and it is like faster than electrical signal. The last suitable for high-speed long-distance network. Structure of fiber optic. From inside this core, inner glass fiber is the path where light travel. Next is cladding, surrounds the core, reflect light back inward. The last one is coating or the jacket, outer protective layer, and it's protect from damage and moisture. Now, how does fiber optic cable works? It uses total internal reflection. The light enters the core at a certain angle and then bounces off the cladding repeatedly, travel forward with low signal loss. It enables long-distance data transmission. The advantage of fiber optic cables are extremely high speed, gigabyte per second, and then it supports long distances like tens of kilometers, no electromagnetic interference, very low signal attenuation, long lifespan, and low maintenance. And the last one is safe. There is no electrical current. Disadvantage of fiber optic cables are higher cost for the cable and installation. It requires special tools like fusion splicer, cleaver, and no TDR. It's fragile, sensitive to bending, and then it cannot carry electrical power. That is the end of my part. In this slide will be explained by Denis. Thank you.
Okay, thank you, Nina. So now I'm gonna explain the types of the UTP cables and their characteristic. So UTP cables first are used for networking. They are divided into several categories from Cat 1 to Cat 8. Each category has different speed, bandwidth, and performance. Okay, next. Okay, so we got here is Cat 1 and to Cat 4. So Cat 1 to Cat 4 are early generation cables. So they have very low speed, less than 20 Mbps. These cables are easily affected by interference. And today, they are no longer used in modern network. Okay, next. Okay, now we have Cat 5 and Cat 5e. So let me start with Cat 5 first. So the Cat 5 has a bandwidth of 100 megahertz and speed up to 100 Mbps. And the range of the Cat 5 is 100 meters. The maximum range is 100 meters. However, it is still sensitive to the interference. Today, it is maybe really used today. And next we have Cat 5e. So the Cat 5e is an improved version of Cat 5. So it is support speed up to 1 Gbps and the distance is still 100 meter, but it has better resistance to the interference. This cable commonly used in homes and small offices. Okay, next. So now we have Cat 6 and Cat 6a. So let me start with Cat 6a first. So Cat 6a has a bandwidth of 500 megahertz and speed up to 10 Gbps. It has a better shielding and very low interference. As you can see right here, the distance is 100 meters. And this commonly used in data center and large network. But Cat 6 has a bandwidth of 250 megahertz and speed up to 10 Gbps. But it is more resistant to interference. This cable is suitable for office and high-speed network. Okay, next. Now we have Cat 7 and Cat 8. So let me start with the Cat 7 first. So the Cat 7 has a bandwidth of 600 megahertz and speed up to 10 Gbps. This cable is fully shielded, so the interference is very low. It is used for industrial and high-end network. And next, we move on to Cat 8. As you can see right here, it has a bandwidth of 2000 megahertz, and the speed it can reach to 25 to 40 Gbps. However, the maximum distance is shorter. It's around 30 meters. And it is used in data center and server. So, in conclusion, higher category cable have better speed, bandwidth, and performance, but they are also more expensive. So we should choose the cable based on our needs. Thank you. So next will be explained by my friend. Take your time.
Next, types of fiber optic. There are two main categories, single-mode fiber and multi-mode fiber. Single-mode fiber carries only a single light path through a very small core diameter, which allows light to travel with minimal reflections, making it ideal for long-distance communications. On the other hand, multi-mode fiber can carry multiple light paths simultaneously, making it easier to work with and more affordable. However, it's only suitable for short-distance transmission. Multimode fiber itself is divided into two types. The first is step index and graded index, and the second is graded index, which is we will cover in the following slides. Next, single mode fiber. As shown in the table, SMF has a very small core diameter of 8 to 10 micrometers and uses a laser light source operating at wavelength of 1310 nanometer or 1550 nanometer. It supports extremely high bandwidths, up to 100 Gbps and beyond, with transmission speeds reaching even the terabit per second scale. One of its biggest advantages is its maximum distance of over 10 kilometers without needing a repeater, along with the very low attenuation of just 0.2 decibel per kilometer at 1550 nanometers. Because of these capabilities, SMF is the go-to choice for large-scale networks such as internet backbones, intercontinental submarine cables, data center interconnects, and metropolitan area networks. Next. The next is multimode fiber step index. We have multimode fiber step index. This type features a core diameter ranging from 15 to 62.5 micrometers and uses a LED light source operating between 850 nanometers and 1300 nanometers. Its bandwidth is relatively limited at 200 to 500 mHz, with transmission speeds of only 10 to 100 Mbps and a maximum distance of 100 to 500 meters. This is because the refractive index of the core is uniform throughout, then drops sharply at the boundary with the cladding, causing different light rays to travel different optical path lengths and arrive at the receiver at different times, a phenomenon known as high modal dispersion. Next. Next is multimode graded index. Multimode fiber graded index is an improvement over step index. It supports a core diameter of 15 micrometers for OM3, OM4, and OM5, or 62.5 micrometers for OM1 and OM2, and uses either a VGSEL or LED light source. Its bandwidth is significantly higher for OM4 examples reaches 4700 mHz per kilometers at 850 nanometers with transmission speeds ranging from 1 Gbps all the way up to 100 Gbps. This is made possible because the refractive index decreases gradually from the center of the core toward the cladding boundary, causing light rays to travel in curved sinusoidal pattern than the zigzag pattern of step index, which results is drastically reduced modal dispersion and significantly increased bandwidth. Okay, next slide will be explained by Nadin. Thank you.
Okay, now I'm going to explain about technical comparison between UTP cable and fiber optic cable. So the first one is from the transmission media aspect, which is part or intermediate 3. For UTP cable, we use electrical signal, and for fiber optic, we use light for signing the signal. And next one is speed. For UTP, is moderate, and fiber optic, it's can be using a very high speed. Next is bandwidth or maximum network capacity. UTP cable have a limited bandwidth, while the fiber optic have a very large bandwidth. For maximum distance, UTP has 100 meters, and fiber optic can up to tens of kilometers maximum distance. And the next is interferences or signal disturbs, which UTP has susceptible to ME, and fiber optic is not affected. Next one is attenuation or signal loss. UTP has a higher signal loss, while fiber optic has a very signal loss. And for the cost, UTP has cheaper cost, while fiber optic has a more expensive cost. And the last is installation. For UTP cable has the easier installation, while for fiber optic has more difficult installation. Next. Now I'm going to explain and tell you for the real world implementation of UTP and fiber optic cable. So for the first implementation is for the home network, which is we using the UTP of Cat 5e types or Cat 6 and fiber optic FTTH. The reason is because it's short network distance and lower installation costs. Also, the bandwidth needs are not too high, and fiber is used to increase internet speed from the ISP. And for the example, like connecting the router to computers, laptops, smart TVs, and other home devices. For the office network, we using combination of UTP and fiber optic for the transmission media. And the reason why we using UTP and fiber optic is because UTP is used for indoor local networks, while fiber optic is used for interfloor connection or backbone networks for faster and more stable performance. For the example is employees' computer, network printers, and interfloor building connection. Next. The third one is campus network. We're using fiber optic backbone and UTP for transmission media because the large campus with many buildings require fast and long distance fiber optic connection. And also UTP is used for the user devices. For example, like computer laboratory, lecture room, access point, and network switch. And the last is data center. We're using fiber optic for the transmission media because it requires very high bandwidth, fast speed, and low latency to support server-to-server communication. And for example, like connection between servers, between server racks and data center network backbone. Next. As we used say before, we can see the conclusion from the presentation that we already talked. So the first conclusion is transmission media in computer network. For the definition itself, it's path for sending data between devices, and the common types uses is UTP and fiber optic. For UTP cable, we can see it's low cost, its installation, so it's suitable for short distance network like homes and small office, and limit bandwidth. It's also shorter distance and susceptible to ME. While the fiber optic usually used in indoor because it has high-speed connection between floors and data centers, and using on outdoor too because it's long distance connection, campus backbone, and ISP networks. It's very high speed and large bandwidths, and it's also resistant to interferences. For the media recommendation by the environment, we can see in indoor, usually using UTP cable because it's short distance devices, or also we can use fiber optic because it's high speed and multi-floor. While the outdoor, we can using fiber optic because it has a long distance backbone networks. And for the final conclusion, we can know that choosing the right media improves network efficiency, performance, and sustainability for user needs. Thank you so much for listening our presentation for today. I hope you guys understand about the material that we already present, and thank you so much for your attention.